Guys, am I audible? And is the screen visible?
Yes.
Okay. So in the last lecture, we ended up with the two mechanism, that is the SN1 mechanism and the SN2 mechanism. In today's class, we'll be talking about the factors that affect SN1 and SN2. Okay. So please write the heading. Also, just give me a minute rather. Yeah. Sorry, I was just checking a few things and let us start. So please write the heading. Factors affecting SN1 and SN. No. There are three factors that we have to understand. First is nature of substrate. Nature of substrate. Then we have nature of leaving group. And thirdly, we have the effect of solvent. Effect of solvent. So first of all, we will look at the nature of substrate, then the nature of leaving group, and then the effect of solvent. That is the last portion. Okay. So first of all, let us look at the nature of substrate. Now, in nature of substrate, we will look at two different reactivity, the reactivity of SN1 as well as the reactivity of SN2. The reactivity of SN1 and the reactivity of SN2. Now, when we talk about the SN1 reaction, we have seen that it happens via the intermediate carbocation. And the reactivity of SN1, it is directly proportional to the stability of carbocation. Okay, so reactivity of SN1, the SN1, it is directly proportional to stability of carbocation. Now, if I look at the SN2, then in that case, the main hindrance is the attack of nucleophile. If I go back, then in SN2, what is happening? In SN2, this is the main issue. How the nucleophile is going to attack the carbon atom and how it can bear these 1, 2, 3 different groups that is attached to it. So the hindrance that is caused by the groups on alpha carbon, this is the alpha carbon, and the groups attached to it, that is the main hindrance or the main barrier. So we can say that the reactivity of SN2, it is going to depend directly proportional. SN2, it will be now inversely proportional to steric hindrance. Either I should write right now number of groups on alpha carbon. If I have more number of alpha carbon, then the attack of nucleophile will be very slow because nucleophile will not be able to find space and it won't be able to attack the alpha carbon atom. Is these 2 points clear? Yes or no? Please tell me, guys, first of all. Yes, Arsalan, Yusuf, Kiram, Krishna, Prem, yeah?
Yes, sir.
Hannah? Tell me.
Can you scroll a bit up? I didn't note that part.
No problem.
I'll just quickly note it.
All of you guys note till here, then I will move and we will do some questions. That is the only thing. Then we will start doing questions and understand the part. You write this down. I'm waiting for Yusuf and Mir. Okay, everyone is done. ठीक. See, now regarding the reactivity of SN1, we have seen that reactivity of SN1, it is directly proportional to stability of carbocation. But we have to understand that carbocation, it is having a positive charge. So what if I'm going to give it more and more electrons, then it is going to be more stable. The first one that we can write is carbocation is stabilized by carbocation. It is this C positive is carbocation, है ना? Carbocation is stabilized by electron donating group, and carbocation I can say is destabilized by electron withdrawing groups. If I'm going to withdraw more electrons, if I'm going to pull out more electrons from the carbon atom, from this carbocation, then there will be an increase in the positive charge, and that's why it will become more destable. So now, what are the things that I can write? If you guys remember, I can write stability of carbocation. It is directly proportional to the plus M effect. It is inversely proportional to minus M effect. I can say it is directly proportional to the plus I effect and inversely proportional to minus I effect. You guys somewhat remember what is plus M, plus I, minus M and minus I? Yes or no, guys? Please tell me. Yeah. Plus M means where you are having electron donating group via mesomeric effect, that is via resonance. Inductive effect is because of the electronegativity difference. Okay. Now, let us see. So there are a few points that you just write. If I talk about the rate or reactivity of SN1, the rate of SN1. This is fastest when you have benzyl haloalkane followed by 3-degree haloalkane, which is almost equal to the allyl. Then you have 2-degree, and then they have 1-degree. What does it mean? I will show you also. So a haloalkane, which is a benzyl haloalkane, the structure is like this. This will be giving fastest SN1 reaction followed by, if you have halogen atom which is connected to a carbon, which is 3-degree, and this and allyl is almost similar. This is allyl carbon having a benzene ring, and then you have the 2-degree halogen atom on a 2-degree carbon, and then you have the 1-degree haloalkane. Please write this down. ध्यान दीजिए. Now, as we have seen, if the carbon, अच्छा देखिए ध्यान दीजिएगा ना, this is alpha carbon. Please try to remember that this is the alpha carbon where you are having the halogen atoms and everything. Now, benzyl पे सबसे ज्यादा है, then 3-degree, then allyl, and then 2-degree. So more the number of benzene ring on alpha carbon, higher will be the reactivity. ठीक है? Higher will be the reactivity. Please understand one more point. The rate is directly proportional to stability of which will be directly proportional to number of benzene ring on the alpha carbon on alpha carbon, and is also directly proportional to number. अच्छा नो नहीं लिखा, number of है, ठीक है, इसको चेंज कर लीजिएगा प्लीज. दिस इज number of. That is R group on alpha carbon. ठीक है, this is very easy to understand ना, benzene ring, because benzene is going to give you the highest reactivity. What about alkyl group? More the number of R group, higher will be the degree of carbon ना. अगर if you have 3 alkyl groups, then it is 3-degree, so it is very fast. Then 2-degree, and then 1-degree. So if you have more alkyl groups around the alpha carbon, then also the reactivity is going to increase. Is this clear? Yes or no? Please tell me, guys.
Yes, sir.
ठीक है,
Yes,
please
sir.
write this down, these 2 points, and then write this question. ठीक है, this is one question itself है ना. इसको हम नेम कर देते हैं. Let us suppose this is A, this is B, this whole thing is B, this whole thing is C, and this whole thing is D. ठीक है? Now the most important thing is that ये structure है क्या? How are you going to make these structures? So it is, तो इसको ध्यान देंगे अगर आप, then the C6H5, it is benzene ring. I'm going to make the first structure. Then CH2, one carbon atom, and then it is further attached with Br. So this is the A structure. Then we are having C6H5, which is bonded to carbon. Then there is a branch. Okay, whenever you see a bracket, bracket is equal to branch. Okay, branch of the previous carbon, है ना? तो देखिए B वाला कैसे बनाया जाएगा? You will have the benzene ring like this. C6H5 connected to a carbon atom. This carbon atom has CH3 and C6H5 also on this carbon, same carbon atom. ना? ये इसका branch है. ठीक है? So you could, I'm not going to make one more benzene ring. Rather, I will just make PH, and then you can add Br here. This is the B structure. And next we have one C6H5 and two C6H5. So I will just write PH that is connected to a carbon atom. And this is having one more PH and then hydrogen and then Br. This is the C structure. And then in the last C6H5, you have a CH3. So PH, and then you have CH, which is having a CH3. And then further you are having a Br. This is the D structure. So tell me which will be the fastest ABCD ka order. I hope you can do that. Right? I mean, using only this particular part, you can say which is going to be the fastest. Directly proportional to the number of benzene ring on alpha carbon. So this is the alpha carbon here, this is the alpha carbon. You have to just count the number of benzene ring. And if the benzene ring is same, then you count the alkyl group. Okay. So please start doing this. I will give you like 2 minutes, I think, 3 minutes. Enough. Take 3 minutes. Send your answer in my WhatsApp. Guys, 1 more minute. Okay, Arslan. Like 30 more seconds, guys. Okay, Krishna sent the answer. Okay. Uh, 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 uh. Yep, correct. Very good, Krishna. Okay, just 10, 14 seconds remaining. Mr. Yusuf has sent. Okay, Yusuf. आपका बी आर इधर उधर हो जा रहा है यूसुफ, अदरवाइज इट इज फाइन. See here, guys. Now we are going to count the benzene rings and the alkyl group, right? So how many pH, how many benzene ring, and how many alkyl group the CH3 group we are having. Here we have one benzene ring, and here we have two benzene rings, and here we have one pH group. Sorry, one CH group. Then moving on to the C structure, here we are having only two benzene rings and zero phenyl. Sorry, two benzene ring and zero CH3 group. Here we are having one pH and one CH3, right? Yeah. So जहाँ पे number ज़्यादा हो रहा है, first of all, let us look at the phenyl. So B and C are having same number of phenyl. So we are going to compare the CH3. So B will be the top, followed by C. Then next one we have A and D. So both of them are having one phenyl group, but CH3 आपका D में ज़्यादा है. So you will have D and then A. ठीक है? I hope all of you got this. Yes or no, please tell me, guys.
Yes, sir.
Yeah, ठीक.
Yes, sir.
No, please. Now, there is a very important question, and please you will understand this question, and then we are going to write it. Okay, so please write the question. Predict the reactivity of for isomeric bromobutane for isobrom in SN1 reaction. Now, please see. When I talk about bromobutane, so there are two structures of bromobutane that is possible. And simple normal bromobutane, ठीक है? Not simple normal bromobutane. When I talk about butane, ठीक है? पहले butane को देख लेते हैं. Butane is made up of 4 carbon atoms, and there are two possible structures. एक तो butane ऐसे हो सकता है, 4 carbon atoms, and I can have 4 carbon atoms in this order. There are 3 CH3, 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 and in the center of CH carbon atom. Now, if I'm going to attach bromine into butane, there are two possibilities from the first structure of butane. I can either attach it in one of these carbon atoms, the 1-degree carbon, or I can attach it in one of these, the 2-degree carbon atoms. Okay. So you'll have one like this, and you'll have Br like this. So these are the two possible bromobutane from the normal butane. Now let us call this A and let us call this B. If I talk about this structure, then it is going to have two structures. One will be when the bromine is attached in one of these carbon atom, and the other would be when the bromine is attached on the central carbon atom. So let us see this. The C structure that we can have, Br, and the CH3 is here. The D structure that we can have is the Br is here. So all of you understood this? Yes or no, please tell me. The 4 isomers of bromobutane. Huh? The 4 isomers of bromobutane. Now let us see what are the carbocation that will be made by these bromobutane. Now reactivity तो उसी पे depend करेगी ना SN1 की, that what type of carbocation they are making. ठीक है? So or rather I can just see the degree of alpha carbon ना, ये भी कर सकते हैं. This is the alpha carbon, this is the alpha carbon, this is the alpha carbon here, and this is the alpha carbon here. Okay. Now let us see. This is what this is going to be a 2-degree alpha carbon. Yes or no, please tell me, guys. Can all of you see it is 2-degree? This carbon atom is attached to one carbon and two carbon atoms. है ना? तो 2 degree हो गया. This alpha carbon is attached to only one carbon atom directly. कितना हो गया? 1 degree. This carbon atom, it is attached to only one carbon atom, right? It's attached to only one carbon atom. That is why it is going to be 1 degree. And this carbon atom here, it is attached to 1, 2, 3. It will be 3 degree. So if I just look at the degrees, then I can see that the D is most reactive, right? After that, we have 2 degree, which is the A structure. Then when I compare the B and D, both of them are 1 degree. But here you can see that here we have two CH3 groups very near. But the carbon atom that is attached to this alpha carbon is the fourth carbon. Connectivity थोड़ा देखिएगा आपको समझ में आ जाएगा. See, this is first carbon, second carbon, third carbon, and fourth carbon, right? So there are 4 carbon atoms, but the fourth carbon connectivity काफी दूर में है. And here you are having 1, 2, 3, 3. So the connectivity of carbon atoms are quite near. That means they push the electron density towards the carbocation very easily. And that is why the C structure will be more stable. And then we'll have the B. Please write this down. Just waiting for Yusuf now. Okay. Now, if I'm going to talk about the reactivity of SN2, that's pretty simple. You have to just remember one factor, that is the degree of carbon. Okay, so this is all about SN1 till here. So please write next reactivity of SN2. The rate that will be present, this will be the methyl halide, that means CH3X, will be fastest, followed by 1 degree, which will be followed by 2 degree. And then followed by the 3 degree. Okay, this is 1 degree. This will be fastest, then 2 degree, and then 3 degree. Because larger the number of bulky groups you are having, if you have more groups, it will be difficult for the nucleophile to attack on the carbon atom. वहाँ पे space ही नहीं रहेगा. So that's the unavailability of space. We call it steric hindrance. There is a note that you have to write, very important note, please write. Alpha unsaturation always decreases the reactivity of nucleophilic substitution. ठीक है, both SN1 as well as SN2 दोनों ही, SN1 and SN2 both. What is alpha unsaturation? Please see. For example, double bond, and then you have halogen here. If I compare this with this type of chlorine, yeah. So obviously here, this particular species, chemical species, this particular compound will be faster. Why? Because here we are having a double bond. Just give me a second. This carbon atom, this is the alpha carbon, and it is having a double bond. And there will be a lone pair here, and that lone pair will be in conjugation. That is why this bond will be difficult to break. Also, if the nucleophile is going to attack on the alpha carbon, it will be very difficult to attack because we are having pi electron cloud. And that double bonded carbon atom is going to repel the nucleophile. Because nucleophile is also having large number of electrons, the pi bond will also have large number of electrons. Okay, so we will see the reason later on, but I'm showing you a few examples. Okay, so in this case, you can see the alpha saturation, and that is the reason why this is less reactive than the normal haloalkane. Then, for example, if you have something like this, and if you have a simple cyclopentane, then the simple cyclopentane will be much faster. Similarly, if you have a benzene ring, in which the chlorine or the halogen is directly attached, then this will be slower than a cyclohexane. Okay. So here also the same thing. This is the alpha carbon, and वहाँ पे unsaturation. That means there is a double bond of the alpha carbon. Now, why it is happening? Please see. It is decreasing the reactivity of SN1. So first of all, we'll see why it is decreasing the reactivity of SN1. Please write with me. In SN1, the carbocation formed is unstable due to presence of sp2 carbon adjacent to carbocation. Okay. Next, in SN2, why it is slower? In SN2, the nucleophile is repelled by electron-rich pi bond, and therefore it does not attack. Therefore, it does not attack. Also, now this, the last reason you can write it for both the cases, SN1 के लिए भी, SN2 के लिए भी. The CX bond in alpha unsaturated compounds, the CX bond in alpha unsaturated compound is partial double bond due to resonance. ठीक है, सोचिए. ठीक है, so this bond here, it is having partial double bond character because एक resonating structure में it is having a double bond. Please write these 3 points. Raise your hand once you're done. Waiting for Yusuf. Okay. Everyone is done. Now, moving towards the easy part, that is nature of the leaving group. Nature of leaving group. Okay. Now, please write here. The leaving group should be able to bear the negative charge. Okay. Hence, larger the size of leaving group, faster is the reaction. Okay. So rate of SN, both SN1 and SN2, no matter what, rate of SN, it is directly proportional to size of leaving group. So we can say that fluorides are least reactive, followed by chlorides, followed by bromides, followed by iodide. So iodides are the fastest. Write this down, and then we're going to do a question. So in this question, you have to say whether this is going to give faster reaction or this one, whether this is going to give a fast reaction or this one for SN2. You can send the answer like this: A will be more reactive or B. This is the A structure, this is the B structure, this is the A structure. Aslan, there are two questions. वो अलग अलग सवाल है. Yes, it's correct. Iram correct, and Aslan also correct. Very good. So in the first question, if you see, okay, जो चीज same है उसको compare नहीं किया जाता है. That is why we are not going to compare CS3 or CS3. We are going to compare Br or iodine, which is going to give faster reaction. So obviously Br is going to give faster reaction. And when I see the structures here, so you are having chlorine same, so we are not going to compare the chlorine. Rather, what is attached on the alpha carbon? So in this B carbon, we are having only hydrogens, and this is having 3 CS3 group. That means this is 3 degree, and this is 1 degree, right? Or rather 0 degree. There is no carbon attached to the alpha carbon. So that's why the B will be faster here also. Krishna Priya has sent. Yeah. Now, write the next one, nature of solvent. Now, there are some results that I will just write it down, and then we will explain this. Okay. So please write. Don't worry about the words and everything. Just write it down, and I will explain everything. Polar protic solvents increase the rate of SN1 and hinders the reactivity of SN2. Next point, polar aprotic solvents are used in SN2. ठीक है, अब समझते थोड़ा है ना, समझते इस बात को, like what is polar protic solvent, what is polar aprotic solvent. Now if you read the first sentence, the only thing that is going to be not, the only thing that is going to be new in this sentence is protic. I hope you guys understand what is polar. Polar means a solvent which is having a kind of dipole moment. जहाँ पे dipole moment हो, that is polar solvent. And non-polar will be meaning that जहाँ पे dipole moment नहीं हो. But what's the meaning of protic and aprotic? So protic just means the solvent which can give H plus ion, that have a tendency to give H plus ion. For example, if you see H2O, okay, so it is bonded, hydrogen is bonded with oxygen atom. The oxygen atom can easily lose the hydrogen because it can gain a negative charge. Similarly, C2H5OH. Here also this OH, this oxygen atom is having. Similarly, CH3COOH. ठीक है, अब यहाँ पे तो the tendency to lose the hydrogen atom, it is even more higher. Why? Because here we are having hydrogen atom which is attached on acid, और acid की तो tendency होती है. So each and every solvent which can give a hydrogen atom, ठीक है, which can give a proton मतलब H plus ion, that is known as polar protic solvent. And all the protic solvent, they will be obviously polar because वहां पे hydrogen पे delta positive charge होगा, and the rest of the compound will be having delta negative charge. Now another good, rather the official definition of polar protic solvent is that the solvent हाइड्रोजन बॉन्ड्स, ठीक है, यानी कि ऐसा हाइड्रोजन जो कि इलेक्ट्रोनेगेटिव एलिमेंट के पास जुड़ा हो, ताकि when the hydrogen leaves, that electronegative element can bear the negative charge. तो बस आप ये समझिए, water, ether, these are the three examples that you have to remember. Now why it increases the rate of SN1, उसको जरा देख लेते हैं. So in SN1 what happens, we are having C positive carbocation. Now when you have carbocation and you are having water as a solvent, so you can see that what water can do, the water will surround the carbocation like this. Now, why is the oxygen part surrounding the carbocation? It is surrounding the carbocation because oxygen is having lone pair electrons. And when this lone pair electron is around a positive charge, you can understand that there will be some kind of interaction, positive or negative के बीच में. And wherever there is attraction between positive and negative, then what's going to happen? The stability is going to increase and the energy is going to decrease. So because of this type of stability, इसको बोलते हैं solvation. A solvent surrounding a positively charged atom or any charged atom, it is known as solvation. And because the carbocation is getting solvated, यहाँ पे आप देख सकते हैं that it is getting attraction from the lone pairs of oxygen atom, and that is why the stability of carbocation will increase. इसके पास इलेक्ट्रॉन की कमी है, and nearby it is having oxygen atom, which is what having lone pair electrons, so that it can lose some electron there. So carbocation की stability क्या हो जाएगी? बढ़ जाएगी. But then you will ask, sir, why it hinders the reactivity of SN2? It hinders the reactivity of SN2 because when you have polar protic solvent, you can see that it is having lone pair electron, water. अब मान लीजिए आपको एक रिएक्शन करानी है इस तरह से, Br plus, let us suppose you are having ammonia, NH3. You want to attack NH3 on this particular carbon atom. And then you are also using water here. तो यहाँ पे क्या होगा? Now there will be a competition. The ammonia atom, it is also having a lone pair electron, so this can also attack on the alpha carbon. अब water के पास भी lone pair है, this can also attack the alpha carbon. Now both the reagent as well as solvent is taking part in reaction. लेकिन हमको तो ये वाला reaction नहीं चाहिए ना, because I'm using water as a solvent, not as a reagent. I don't want the product to be having OH group. I just want the product to be having the ammonia amino group, right? So what is happening? The H2O is hindering on the reaction when we are having SN2 reaction. That is why we never use polar protic solvent in SN2. We only use polar aprotic solvent in SN2. Is this clear? Yes or no? Please tell me. ये बात आपको समझ में आई? इसको हम पहले लिख देते हैं यहाँ पे क्या हो रहा है एक्चुअली में. Then you will understand it more. Polar protic solvent increases the rate of SN1 by stabilizing the carbocation. Then you will write polar protic solvent hinders, or rather decreases the rate of SN2 by attacking the substrate. Please write this whole thing down. You don't need to write this part where I'm explaining. इसको लिखने की जरूरत नहीं, but write the 4 points. I'm waiting for Yusuf and Mir. Just waiting for Yusuf now. Yusuf, please raise your hand if you're done. Okay, I don't think Yusuf is writing. Now, these are the different factors. And next, we are going to look at the reactions of SN न्यूक्लियोफिलिक सब्स्टिट्यूशन में क्या रिएक्शंस होते हैं? राइट हेडिंग SN reaction of alkene. ठीक है. Now I'm going to write a few reactions. ठीक है. You are just going to copy it down and then आपको थोड़ा वो याद रखना पड़ेगा ना. And also it's not very difficult. It is quite logical. All the reactions that we are having in the SN reaction, all these reactions are quite logical. And there I will also tell you which of the reactions are more important and where you have to focus more. Just give me a second. See, don't write now. I will explain this. See, we have haloalkane that is reacting with NaOH or KOH. So NaOH, it will dissociate into positive and OH negative. This OH negative is going to attack on the alpha carbon. As it attacks on the alpha carbon, the halogen will leave and then you will get alcohol R bonded to OH. This carbon atom then bonded to OH. Similarly, water is going to a similar type of reaction. The water molecule is going to attack and then later on. Then if you look at this particular reaction, though we negatively charged part, you have Na positive and this part is negatively charged. So this carbon atom, it is going to attack on the R group. You can see R, C, triple bond C, and then R, that is the R of haloalkane. Then in NH3, we have the lone pair. This lone pair is going to attack on the alkyl group. And then the hydrogen will leave later on. When you see R dash C double bond O, Ag, then here it is like this, R, C double bond O, oxygen, and then Ag positive, and oxygen is negatively charged. So this oxygen atom, it is going to attack on the alkyl group. So you can see that this R dash is as it is, C double bond O, then O, and then we are having this R here. In LiLH4, hydride is having negative charge. Hydride is present as H negative, and that is why H negative attacks on the R. It replaces the halogen atom. Then in KCN, CN negative is acting. CN negative is acting as a nucleophile, and that is why CN replaces the X. Now in AgCN, the attacks happen via nitrogen. That is why we get RNC. In NO2, the attack happens via oxygen. That is why we get ONO. In AgNO2, the attacks happen via the nitrogen atom. That is why we are going to have RNO2. Please write this down. We'll do a few questions. उसके बाद आपको ये products वगैरह याद हो जाएंगे. It's not very difficult. You have to just remember what to replace. When you have aqueous NaOH or aqueous KH or water, then X is replaced by OH. Now, this is going to be used only in this particular thing. It is going to be used only in one reaction of doing conversions, not many much. NS3 is going to be used, and LiLH4 is important so that you can easily go from haloalkane to alkane. Okay, please write this down. Then we will do some more questions. Raise your hand once you're done writing. Waiting for Yusuf, Arslan, and Idam. See here. Okay. Now, can you tell me? I will do one for you guys. एक बता दीजिए. I will do one for you.
So
Tell me which
first
one should I do? First one only. अच्छा. तो देखिए सबसे पहले तो you will see the substrate and then you are going to look at the reagent. तो reagent में what is going to attack? KOH में क्या attack करने वाला बताइए guys? What is going to attack from KOH?
BR.
KOH में से क्या अटैक करेगा भाई? BR कहाँ से आ गया? BR तो है ही नहीं KOH में.
Oh, हाँ.
OH is going to attack, right? तो यहाँ से ऑक्सीजन एटम is going to attack and आपको BR हटा के बस OH डाल देना है. ठीक है, ये समझ लीजिए. आप इसको ऊपर से कॉपी करना है आपको, है ना. X की जगह OH लग गया तब when you have aqueous KOH और aqueous NaOH. अब देखिए जैसे यहाँ पे CN है ना. So you will write each and everything as it is. जो ये सबस्ट्रेट में जैसे लिखा हो बिल्कुल वैसे लिखना है. But you need to replace X, that means halogen, क्योंकि क्लोरीन है यहाँ पे. क्लोरीन हटा के क्या लिख देंगे बताइए गाइस. Tell me if you are having CN, KCN है ना, तो क्लोरीन को हटा के क्या लिख दिया जाएगा बताइए. Tell me. CN. ठीक है, बिल्कुल सिंपल है, बिल्कुल कीजिए ऐसे ही. Look at the products that we have written. You will remove the halogen atom and then add the nucleophile there.
It is.
Write this down, guys. I will give you 3 minutes, and in 3 minutes, whatever you are doing, you will send it to me, and then you will start doing once again. है ना? I will ask you guys to send your answers. I'm giving you guys 3 minutes. Okay, Krishnapriya, you have done some. Yes, very good, Krishnapriya. Those are fine. You can keep doing. Yes, you don't have to send each one. Okay, Krishnapriya.
No, sir. I got the
Uh,
iodopentane and hexapentane mixed up. That's
I think that is fine.
no. In this, the third question was with H2O. I think the first one I sent, I did it with AgCN.
Acha, okay, fine. But still, I mean, even if you wrote AgCN, I mean, the answer is still correct. Don't worry. I mean, according to AgCN, it is correct. The reaction is right only, no? You have copied the question wrong, no problem. It's fine. Yusuf, Yusuf is done. In OH, yes, correct. NO2 and CONO. Yeah, very good, Yusuf. Very good. CNOH, NO2. Oh. Please check the AgCN1, Iram. Please check the AgCN1. Aslan, first is correct, second correct, third is correct, fourth is correct, fifth is also correct, and the sixth one is also correct. Yeah, very good. Iram, you got the mistake in the
Yes, so it's NC.
AgCN1. NC होगा हाँ. Here it will be CN. Here it will be OH. Here it will be NO2. And C. ONO. Those who are not done, please write it down. Those who are done, you can raise your hand. Raise your hand if you're done. Just waiting for Mir. You have to understand. Now, write a note. Right, there is something known as ambidentate nucleophile. Please write. Ambidentate nucleophile. What is ambidentate nucleophile? It is nucleophile that has more than one atoms. It has more than one donor atoms, but can attack by only one of them. ठीक है? Possibility दोनों से है कि when it is going to attack, then किसी एक से ही करेगा. It can be any one of them. Can be any one of them. ठीक है? Please understand. Both are having the capacity, बस उसमें से किसी एक से ही attack हो पाएगा. ठीक है? You have to learn for the ambidentate nucleophile is the CN, C triple bond N, in which nitrogen is having lone pair and carbon is having also a lone pair, and due to this, it's having a negative charge also. Now, here you can see that the carbon atom can also attack, right? And the nitrogen atom can also attack. But any one of these is one of them is going to attack. The other one is ONO, that is NO2. Right. Now this oxygen is having two, the nitrogen is having lone pair. You can see that the attack can be done by either nitrogen, and if I compare one of these oxygen can also do the attack, because एक के पास negative charge, that's why the chances of attacking the negative charged oxygen atom is more. But still we can say that दोनों में probability ज़्यादा है, दोनों probability है oxygen की भी और nitrogen की भी. ठीक है? So the cyanide nucleophile and the nitro NO2 negative, both of them have more than one donor atom, है ना? एक से ज़्यादा उसमें donor atom होते हैं. ठीक है? These are known as ambidentate nucleophile. Now, here only, you will see that in CN negative, carbon has higher tendency to attack alkyl group, the alkyl group, as carbon-carbon bond is stronger than carbon-nitrogen bond. ठीक है? If you are having CN negative, then वहां पे probability किसकी ज्यादा होती है? कार्बन की. Majorly, carbon is only going to attack. Why? Because the carbon-carbon bond is stronger than carbon-nitrogen bond. Now, what about O and O? What about the nitro group? Now, in this nitro group, you can see that either nitrogen is going to attack or oxygen is going to attack, है ना? अब इसमें से बात आ जाएगी which is more electronegative. इसके पास, I mean, which is reluctant to attack. जो which is more electronegative, जो ज्यादा electronegative होगा वो attack अपना इलेक्ट्रॉन ही देना चाहेगा. And nucleophile, it gives the. That is why we can say that nitrogen is going to attack, right, like this. Nitrogen has higher tendency to attack as it is less electronegative than oxygen. All of you got this? Sonobi, Shalmi, Yusuf, Arslan, Krishna Priya, and Meer.
Yes, sir.
Okay. Please see. Now, with this information, we are going to explain why KCN is going to give RCN and why AgCN is going to give RNC. KNO2 gives ONO and AgNO2 gives NO2. I mean, AgNO2, it is going to give nitro group. Just wait a second, यहाँ पे. Oh, okay, sorry. Here it is having negative charge, na? Can you please change this here? I think oxygen, yeah. Oxygen is having negative charge. Now you have to write it like this. Oxygen has higher tendency. My bad, guys. Has higher tendency to attack as it is having negative charge. Please, my bad, guys. I forgot that it is having negative charge. So a negative charge की tendency ज़्यादा होगी to move towards the alpha carbon of haloalkene because alpha carbon will contain some partial positive charge. Now please see. Write the heading. KCN versus AgCN. Now, what happens in KCN is listen. KCN is ionic in nature and dissociates to K positive and Cn negative. And we have seen that, and in Cn negative, carbon attacks to form RCN as carbon-carbon bond is stronger. ठीक है. Next, what happens in AgCN? So actually AgCN is covalent in nature. So you have a structure like this, Ag that is bonded to carbon, which is triply bonded to nitrogen atom. Now in AgCN, only nitrogen has lone pair in nature, and only nitrogen has lone pair which can attack the alkyl group, rather the haloalkene लिख लीजिए, and form RNC. RCN को बोलते हैं alkyl cyanide, and RNC is called alkyl isocyanide. Raise your hand once you're done. यहाँ पे लिख लीजिएगा that here we are talking about KCN, here we are talking about AgCN.